Hello everyone, welcome to my channel. Today I am back with a new lecture. I will discuss the basic logic gates, their definition, and then we go to the practical simulation of each of the logic gates. What is logic gate? The logic gate is the most basic building block of any digital system including computers. Each one of the basic logic gate is a piece of hardware or an electronic circuit that can be used to implement some basic logic expression. What does that mean? What is logic gate? Logic gate is the basic or primary unit of any digital system that we use in our computers or in other hardwares. So the logic gate is a hardware or an electronic circuit that we use to perform work and a function, anything else we want from the desired input, and then we get the output from that input. So the logic gate is the most basic building block of any combinational logic. This is the primary unit. There are three basic logic gates, namely the OR gate, the AND gate, and the NOT gate. These three gates are the basic or primary gates of the logic combination, and other three gates and the other gates that are derived from these three gates are NAND gate, the NOR gate, the exclusive OR gate, and the exclusive NOR gate. All these gates are derived from these three gates, OR, and NOT gate. So we will discuss these three gates in our first lecture. What is OR gate? An OR gate is a logic circuit with two or more inputs and one output. The output of an OR gate is low only when all of its inputs are low. So in this definition, there are two things to remember, and these two things I have summarized in this form. So this is symbol of the OR gate, and this is the truth table of OR gate. So symbol defines as that there are two inputs in OR gate, input A and input B, and then this is the logic system. This system, our inputs goes through this system, and we get a result here in the form of Y, in the form of output. And what operation performs here? Their operation is A plus B, and this read as A or B, and we are ORing A and B and get our output results. So this is the truth table of OR gate: A, B, and this is the output. These two are the inputs and this is the output. So our important condition is that an OR gate is zero only when both of the inputs are low. Low means zero. So here 0 0, we get 0. So you must remember that this thing, all other combinations we get 1 1 1. So next gate, AND gate. What is AND gate? An AND gate is a logic circuit having two or more inputs and one output. The output of an AND gate is high only when all of its inputs are in the high states. So this is the same thing that we use in OR gate. So this is the opposite form of OR gate, and similar type of results we get in there. So input A and input B, A dot B means A ANDed with B. So through this logic system, our inputs goes through this logic system and we get our output here. So you must remember this symbol and the condition. Now what's the condition? Condition here is that the AND gate is high only when all of inputs are in the high states. So AND gate will give us some output only on when both of the inputs are high. Means both of the inputs are high, 1 1, we get 1, and all the results with 0 0 0 1 1 0, these combination fails and we give nothing, we get nothing here. So only result is that 1 1 is 1. Not gate. So not gate is the second name of not gate is inverter. So it act as an inverter. A NOT gate is a one input, one output logic circuit whose output is always the complement of the input. That is, a low input produces a high output and vice versa. So this symbol act as a inverter. We give some input and we get some output of that input in the form of complement. Here our input is x and we get the output in the form of x complement. So what does x complement means? If x is 0, then x complement is 1. So and vice versa, if x is 1 and the x complement would be 0. So this is the operation that NOT gate performs, and this operation also called inverter. So let's now move forward through the multisim to verify all of these gates.